Question 4. M is a group 2 metal that forms a nitrate MnO32. 0.32 grams of MnO32 is heat stronger than decomposed completely. The mixture of the gases formed has a volume of this. Determine the MR of MnO32. Identify M. Now this question, I'm pretty sure, came up on my mock, November mocks, and I struggled really badly with this. Obviously, I calculated the number of moles, PV cut, NRT, and I just was confused. But if you read the question properly, which I did not do, I tried my best to, but I clearly didn't. M is a group 2 metal. This decomposes completely, and the mixture of the gases formed as this. So what we can do is we can find out the moles of this, then the moles of this, then the MR of this, and then that's how we get it. So we know PV using ideal gas equation equals nRT. N is equal to PV divided by RT. So let's convert the units. They give you marks as well for converting units in the mark scheme. So volume, well, we want it in meters cubed, we don't want it in centimeters cubed. It's going to be 225 times by 10 to the power minus 6. Temperature, well, we need temperature in Kelvin, it's in degrees Celsius. Temperature equals 450 plus 273 to convert to Kelvin, and from Kelvin to degrees you just subtract 273. 450 plus 273, 723 Kelvin. And the volume is obviously in meters cubed. Now we can substitute it in here because the pressure is already in pascals. Now don't try to convert it. It gives you it in this case. Maybe to try trick some students off who just always convert every single unit without even looking at it. That is me as well. But in this case, pressure is in pascals, so we don't need to convert it. So N is equal to 100,000 times by the volume in meters cubed, which is 225 times by 10 to the power minus 6, divided by R, which is 8.31 in joules K to the power minus 1 multiplied minus 1, 8.31 times by temperature in Kelvin is 723. N is equal to 123 times by 225 times by 10 to the power minus 6 divided by 8.31 times by 723. The number of moles is 3.74 times by 10 to the power minus 3. Oh, it's not 100,000, it's 101,000. So reading the question properly as well. 101,000. So what I might start doing for my next mock, so maybe you guys should do it as well, maybe for your actual A levels, is just get a highlighter and highlight the key details in these mathematical kind of questions. So N is equal to 3.78 times by 10 to the power minus 3. So this is the moles of this whole thing. Yeah, we want to obviously find out the moles of this. Well, what's the molar ratio? It's 2 to, how many moles are here? 4, 5, 6. That's obviously just going to be 1, 2 to 7. So what we want to do is we want to divide this by 7 and then times it by 2. And that's the simplest way of looking at it, and that's the way I'm going to approach it. And I get 1. No, we're not doing that, sorry. What we're going to do to find out the moles is going to be 3.78 times by 10 to the power minus 3 times by 2 over 5. Because there we go, another trick. we don't have, this is the moles of gas, this is a solid, so we only have actually 5 moles of gas, so it's a 5:2 ratio. Yeah, because there's only 5 moles of gas, don't want the solid, so it's going to be divided by 5 times by 2. Which will give me 1.51 times by 10 to the power minus 3. And this is the moles of MnO32. MnO32. So now we want to find out the MR. Well, moles is mass over MR. Moles is mass over MR. MR is mass divided by moles, which is going to be the mass of this, which is 0.320. 0.320 divided by moles, 1.51 times by 10 to the power minus 3. 0.320 divided by 1.51 times by 10 to the power minus 3, which give me MR of 211.9. And then therefore to find the identity of M, well, firstly we know now that the total MR is 211.9. So what we need to do to find out the AR of M first, 211.9 minus all of this. So nitrogen 14, yeah, so it's going to be 14 plus 14 plus 16 plus 16 plus 16 plus 16 plus 16 plus 16. 124, 124.0, 211.9 minus 124.0 give me 87.9, and that is the AR of M. But we don't want that, we want the identity. What is M? What is the element M? Well, now we go to a periodic table and we look for 87.9. So this might take quite a while. But here we got strontium 87.6. Well, that is really similar to 87.9. It's only 0.3 away. So therefore the element is going to be strontium. It's going to be strontium, which is SR. Bracket strontium. And now that's it. 5 marks. Just one thing again, you know, that tricky thing, it's not 2 to 7 mole ratio, it's 2 to 5, because we use PV because nRT, N is equal to PV over RT, the number of moles of gas, you know, it's called the ideal gas equation. So once we got the number of moles of gas, well, it's going to be the 4 here, 4 NO2, and 1 here from O2, which is 5, 2 to 5 mole ratio, divided by 5 times by 2, the MR is mass divided by moles, and then you can find out the MR of MnO32. Then to identify M, well, it's just going to be the MR minus all of this, which will give you the M, and we do not include the 2 when calculating the MR. But that's a really tricky thing, the 2 to 5 mole ratio for the moles of gas. I feel like that's the reason maybe I got it wrong with the mark. Maybe, maybe not. But that's the end of question 4.